Look up. What do you see? Is it just the sky, or is there something more? The sun, maybe some clouds, and a vast blue sky. It's a sight so common that we rarely give it a second thought. We often take this sight for granted, but have you ever stopped to wonder why the sky is blue? Why not green or red or any other color? It's a question that has puzzled humans for centuries, and the answer lies in the fascinating world of light and our atmosphere. The interplay between sunlight and the gases in our atmosphere creates this beautiful blue expanse. Throughout history, cultures have created myths and stories to explain this celestial canvas. From gods painting the sky to mystical creatures, these tales reflect our deep curiosity and wonder. Yet the true explanation is even more awe-inspiring. It's a story of science, of tiny particles and waves of light interacting in ways that are both simple and complex. It involves basic physics, the composition of our atmosphere, and a phenomenon known as Rayleigh scattering. When sunlight enters our atmosphere, it collides with molecules and small particles, scattering in all directions. Understanding this process unveils the secrets not just of the blue sky, but also of colorful sunsets, the reddish hue of the sun at midday, and other atmospheric wonders. The sky's colors are a daily reminder of the intricate dance between light and matter. When sunlight, which is made up of all the colors of the rainbow, passes through the atmosphere, the shorter blue wavelengths are scattered more than the other colors. This scattering causes the sky to appear blue to our eyes. As the sun sets, the light has to pass through more of the atmosphere, scattering even more and allowing the reds and oranges to dominate the sky. This is why sunsets are so vibrant and full of warm colors. From ancient times to modern science, our understanding of the sky has evolved, but our sense of wonder remains the same. The sky is a canvas painted by the laws of physics, a daily masterpiece that invites us to look up and dream. So next time you look up, take a moment to appreciate the science and the beauty of the sky. It's a familiar wonder that connects us all, a reminder of the incredible world we live in. To understand the blue sky, we need to start with light itself. Light from the sun travels millions of miles through space to reach us. This light may seem white or yellowish, but it's actually a mixture of all the colors of the rainbow. We can see these colors when light is refracted through a prism. Each color has a different wavelength, with red having the longest and violet the shortest. When these wavelengths are combined, we perceive white light. However, when sunlight enters the Earth's atmosphere, it encounters various particles and gases. This interaction is key to understanding why the sky is blue. As sunlight enters our atmosphere, it collides with tiny particles of nitrogen and oxygen, the most abundant gases in the air. These gases play a crucial role in the way we perceive the color of the sky. This interaction causes the light to scatter in different directions. The phenomenon of light scattering is a fascinating process that helps us understand why the sky appears blue. This scattering, known as Rayleigh scattering, is more effective at shorter wavelengths like blue and violet. Rayleigh scattering occurs when the particles causing the scattering are much smaller than the wavelength of the light being scattered. This means that blue and violet light are scattered more widely across the sky than other colors. However, our eyes are not as sensitive to violet light, and much of it is absorbed by the upper atmosphere. While all colors of light are scattered, our eyes are more sensitive to blue, making the sky appear blue to us. The human eye contains cells called cones that are more responsive to blue light, enhancing our perception of the blue sky. Think of it like this. Imagine throwing a handful of marbles of different sizes into a pool of water. The way these marbles scatter can help us visualize how light behaves in the atmosphere. The smaller marbles would scatter more widely than the larger ones. This analogy helps us understand why shorter wavelengths like blue scatter more than longer wavelengths like red. Similarly, blue light with its shorter wavelength is scattered more widely by the atmosphere than red light. This scattering effect is what gives the sky its characteristic blue color during the day. During sunrise and sunset, the sky can appear red or orange. This happens because the sun is lower on the horizon, and its light has to pass through a greater thickness of the Earth's atmosphere. The increased distance causes more scattering of the shorter blue wavelengths, leaving the longer red and orange wavelengths to dominate the sky's color. This is why we often see such vibrant and warm colors during these times of the day. The beauty of the sky's colors is a direct result of the intricate dance between sunlight and the Earth's atmosphere. So the next time you look up at the sky, remember the science behind its stunning colors. The blue sky is not just a backdrop, it's a testament to the wonders of light and the atmosphere. Whether it's a clear blue day or a fiery sunset, the sky's colors are a beautiful reminder of the natural processes at work above us. And as day turns to night, the sky continues to captivate us, transitioning from the blue of daylight to the deep star-studded expanse of the night. The sky, in all its hues and shades, holds secrets and stories that have fascinated humanity for centuries. It's a canvas painted by the universe, inviting us to look up and wonder. So keep looking up and let the sky's secrets inspire you. It might seem strange that sunlight, which appears white or yellowish, contains all these colors. We can demonstrate this with a simple experiment. Take a white piece of paper and hold it in direct sunlight. You'll notice that the paper appears white. Now take a prism or even a glass of water and hold it in the sunlight. Let the light pass through the prism and shine onto the paper. You'll see a spectrum of colors similar to a rainbow projected onto the paper. This experiment shows that sunlight, though seemingly white, contains all the colors of the rainbow. Section 5. Scattering light, a matter of size. The reason why blue light is scattered more than other colors lies in the size of the particles in the atmosphere and the wavelengths of light. When sunlight enters the Earth's atmosphere, it encounters various particles and gases. These particles and gases interact with the light in different ways, depending on their size and the wavelength of the light. Rayleigh scattering is most effective when the particles scattering the light are much smaller than the wavelength of the light itself. This phenomenon is named after the British scientist Lord Rayleigh, who first described it in the 19th century. Rayleigh scattering explains why the sky is blue during the day, and why we see red and orange hues during sunrise and sunset. The molecules of nitrogen and oxygen in the atmosphere are much smaller than the wavelengths of visible light. These molecules are the primary scatterers of sunlight. When sunlight, which is composed of different colors, passes through the atmosphere, the shorter wavelengths of light, such as blue and violet, are scattered in all directions by these tiny molecules. However, the size difference is most pronounced for blue and violet light, which have the shortest wavelengths. Blue light has a wavelength of about 450 nanometers, while violet light has an even shorter wavelength of about 400 nanometers. Because these wavelengths are so short, they are scattered much more effectively by the small molecules in the atmosphere. This explains why these colors are scattered more prominently, making the sky appear blue to our eyes. Although violet light is scattered even more than blue light, our eyes are more sensitive to blue light and less sensitive to violet light. Additionally, some of the violet light is absorbed by the upper atmosphere, which further enhances the blue appearance of the sky. This scattering effect is a beautiful demonstration of the interplay between light and matter, and it helps us appreciate the natural world in a deeper way. Section 6. Why not violet? If violet light has an even shorter wavelength than blue, why isn't the sky violet? There are two main reasons for this. First, the sun emits a greater amount of blue light compared to violet light. Second, our eyes are more sensitive to blue light than violet light. While violet light is scattered in the atmosphere, our eyes are less efficient at perceiving it. Therefore, the combination of the sun's spectral output and our eyes' sensitivity leads us to perceive the sky as blue rather than violet. Section 7. Red sunsets and other colorful phenomena. Rayleigh scattering also explains why sunsets and sunrises often appear reddish-orange. As the sun dips below the horizon, sunlight has to travel through a larger portion of the atmosphere to reach our eyes. This longer path through the atmosphere means that more of the blue and green light is scattered away, leaving the longer wavelengths of orange and red to reach our eyes. This is why sunsets and sunrises often display such a breathtaking array of warm colors. Section 8. Conclusion. The blue sky's symphony of light. The blue sky, a seemingly simple observation, reveals a complex and fascinating interplay of light, matter, and our own perception. Rayleigh scattering, the phenomenon responsible for this celestial hue, reminds us that even the most commonplace sights can be explained through the elegant laws of physics. Next time you look up at the vast expanse of blue above, take a moment to appreciate the science that paints this canvas. It's a reminder that the universe is full of wonders waiting to be explored, understood, and appreciated. Section 9. Looking Up and Beyond. Understanding why the sky is blue is just the beginning of exploring the many wonders of our atmosphere and beyond. From the aurora borealis's dancing lights to the Milky Way's starry band, the universe offers endless opportunities for discovery and awe. So keep looking up, keep asking questions, and never stop exploring the vast and fascinating universe we call home.